So I would like to start with what is computer architecture and what is computer organization once again, because somebody has posted a question, what exactly is architecture? So what is an architecture? If you think of computer architecture, or if you think of how a computer is built, so computer is built with many functional components. Okay, I'm so sorry. So computer architecture deals with the interconnection of these digital components, these digital functional components. So let's say you know how to design an adder, you know how to design an ALU, you know what is the function of an input unit, you know what is the function of a memory, you know what is the function of an output unit. But when we collectively connect each other and then it realizes a particular function, so we say this is the computer architecture. So this deals with what we call it as computer architecture. Basically, how to integrate the components to build or to realize the desired functionality. These days, you might have seen, we are generally discussing about general purpose architecture. But these days, people are also targeting computational or design specific architecture. You know, what kind of designs are more popular? If you think of artificial intelligence, there you will see that some specific operation is performed many a times. So we might demand a kind of architecture where we can perform those operations efficiently. So there could be demand for domain-specific architecture. So nowadays people are looking mostly into all these kinds of architecture. So this is all about computer architecture. And what is organization? Organization is nothing but the components, the functional blocks using which the computer system is built. So separately, we can think of all these things. Most specifically, if I give you an analogy where you can think of an architect engineer for building a house, you need civil engineers who will specifically make those designs. Okay, where will be your drawing room, where will be your kitchen, where will be your bedrooms, etc., etc. But the overall architecture is designed by an architect engineer. So this is an analogy I often use when I say about what is organization and what is architect. Sir, you can take over and take up other questions.
Okay, sure. Let me start with a question which was related to the MIPS assembly language. In fact, it was related to stack, how stack can be used. But before that, let me tell you very quickly, this was already covered in the classes, the main differences between the RISC and the CISC architectures. Like, as you know, the classical architectures which have evolved with the Intel family of processors, those are traditionally being referred to as complex instruction set or CISC architectures. Now, one of the characteristics of this architectures is that we have a large number of instructions. Instructions vary in types and complexities. The length of the instructions may vary. There can be a large number of addressing modes, lot of variations, and so on. Now, because of these variations, one problem that the computer designer faces is that when you design the hardware to implement this organization, these architectural components, it becomes a little complex. The hardware becomes quite complicated, and instruction execution time, because there are so many variations, is often not very optimized. In contrast, the reduced instruction set or the RISC philosophy, there we say that instructions are simple. They are you can say a small subset of what is available in CISC. All instructions are of the same length. We have a few addressing modes only. And most importantly, only load and store instructions can access memory. All other instructions will be accessing some of the internal CPU registers. Because of this kind of architectures, we need a lot of registers. So typically you will find that in RISC, the number of registers are typically quite large, 32 or 64 or even more. Okay. Now coming to the question, one of you asked that, that how we can implement stack in MIPS kind of architecture. Now, if you recall, we discussed the instruction set. There is no explicit stack in the MIPS architecture or in the MIPS processor. See, normally in a conventional processor like the Intel ones, whenever there is a subroutine call or a function call, normally the return address is automatically pushed in a stack. The stack is a region of memory area, and there is a special register called the stack pointer which keeps track of the top of the stack. So when you push, automatically the stack pointer gets updated. But in RISC, as I said, in MIPS architecture, MIPS processor, there is no stack pointer, because of which we cannot directly support stack in memory. But you can think that using register indirect and register indexed mode of addressing, you can simulate something similar to a stack, because any of the available registers you can use as a stack pointer, and instead of push and pop, you can use some kind of indexed load and store instructions to write something into memory, which will be similar to a push, or load something from memory, which is similar to a pop. Okay. And if you recall, when there is a function call, the return address is automatically stored in one of the registers, R31. So in your program, you will have to explicitly push this R31 in the stack. Automatically, the call instruction will not do this for you. Okay. This is, I think this answers the question. And there was another question regarding floating point arithmetic. The question was, how do we divide mantissa, do we align mantissa, and so on? You see, you just remember, a floating point number is represented by a two tuple. There's a mantissa part, there's an exponent part. The mantissa part basically represents the fractional part, and the exponent represents 2 to the power something. That is the exponent part. Now, when you add or subtract numbers, two numbers are there, you are either adding or subtracting. So unless the exponent values are equal, you cannot directly add or subtract the mantissas, right? So because of this, we need a process called mantissa alignment. Depending on the relative values of the exponents, you will have to shift one of the mantissas to the right or to the left to make them aligned. That means exponents will be the same. And once you have done this, you can directly add or subtract the mantissa values. And after addition and subtraction, you do a process of normalization. So normalization, you know, we try to increase the number of significant digits in the mantissa as much as possible. So if the sign bit is 0 or 1, the next bit following that will be the reverse bit. If the sign bit is 0, we try to bring a 1. If the sign bit is 1, we try to bring a 0. Okay. Now, if we think of multiplication and division operations, the process is simpler. We do not have to do this alignment. Two floating point numbers, when you multiply or divide, the mantissa and exponents are handled separately and independently. For example, in case of multiplication, the exponent values can be directly added. Okay. But for division, the exponents will be subtracted. And the mantissa values individually will get multiplied or they will get divided. No alignment is required. But after the multiplication or division operation is done, you will have to possibly do some adjustment in the mantissa so that it becomes normalized. That is the idea. Okay. So this was the question. There was another question. This was a general question. The question says, I am working in a semiconductor company. After going through this course, I realized that I want to go into more depth of this field. I would like to see myself in that position where I can architect or at least assist in research. How can I achieve that without doing PhD? Is there any other way? You see, my answer to this will be, you can be a very good engineer even without doing a PhD. When I say you can be a very good engineer, I mean that you can be an architect, whereby you can design a computer systems, you can analyze a computer system. See, here we are talking in the context of computer architecture, right? So you can design and evaluate and compare the performances of computer system yourself. See, this course is more like a preliminary course, first level course. But you see, whenever we design some hardware systems nowadays, we normally do not directly start building the hardware. There is something called hardware description languages. We normally design the different functional modules using those hardware description languages. Typical examples are Verilog, VHDL, System C, and so on. So to have expertise in that, you have to have very good knowledge in at least one of these hardware description languages. Now, once you have that knowledge, you can design the different functional blocks that constitutes a computer system. You can analyze them through simulation or emulation various ways, and then you can carry out various kinds of functional studies. So, solid knowledge of computer architecture, a good knowledge of hardware design. I just give an example using Verilog or any other language. So like this, you can possibly build up your background and expertise so that means you can have meaningful contribution in whatever you're trying to do. Well, there are a few questions in the YouTube chat. There is a question on by Vikram Shirol. How can you relate architectural design in software engineering with computer architecture models? You see, software engineering models and computer architecture models are sometimes distinctly different. So sometimes you cannot directly relate the two. Like I'm giving an example. When you usually think about software engineering techniques, you have some software model in your mind. And let's take an instance. Suppose I am concentrating on Java programs. So I will know how a Java program is structured, what are the different constituents, the different methods, how are they called, and so on. So I know that Java programs are getting compiled into bytecode and then they're interpreted. Okay. Now in that level, I am visualizing my software. And with respect to that model, I look at various software engineering or software analysis things, like I can think of software testing, generating of test suite, carrying out reachability analysis, and various other things I can do. But when you talk about computer architecture, you need to know how your hardware is structured. See, when you do software engineering, you need not know how the hardware looks like or how the hardware is structured. What is the kind of pipeline architecture inside? You need not know about that. However, if you are a compiler designer, when you are writing the translator, high level language to machine language, then you need to know the details about the computer hardware, how the computer architecture is. But if you think about software engineering, then computer architecture and software engineering are not directly related. They are models of systems at two different levels. One is the underlying hardware, other is the software which is running on top of that. Okay. Let's see. I am a student of CISC with machine language and AI. Is this useful for me or not? You see, you are a student of computer science, right? Well, you may specialize in any field. You may specialize in information security. AI ML is the buzzword today. You can specialize in AI ML. You can specialize in theoretical computer science, whatever, networking, anything. But you must be very solid or strong in the basic computer science subjects like data structure, algorithms, computer organization, operating systems. Because without knowing these things, you cannot meaningfully carry out your research or whatever you're doing too much further. Well, you may be doing AIML, but unless you understand the underlying machine on which you're trying to run, like let me tell you, maybe Professor Datta can add this AI ML, the kind of techniques we use. For example, the neural networks. There are a lot of architectural, you can say, linkages with that. Today,
Yes.
we have special architectures on which these kind of applications can run more efficiently. So we need to know about this very well. Otherwise, the computer system will be a black box to you, as if you're writing an application. So there will be no difference between you as a computer scientist with someone else who is a non-computer scientist. Both of you will be like an user of a computer system. So Professor Datta, do you want to add this?
Yes, I can add something here that you see today why we are able to perform this machine learning in an efficient way. What we are using? We are using uh, GPUs, we are using TPUs. Okay, so we are using some devices which are architecturally way advanced than general purpose computer. General purpose computers are designed and targeted towards a specific task or towards more general task, you can say. But now with AI and machine learning coming into picture, what kind of operations are more performed? What kind of operations are mostly performed? You can think if you are doing AI and machine learning, matrix vector multiplication is one of the very major operation that is carried out. So how we can efficiently do it? In a general purpose computer, you know there will be specific steps that will be required to perform this task. But as in machine learning or in AI, you repeatedly use these instructions again and again. So you are performing these operations again and again. So you need some kind of architecture, domain specific architecture for these AI based systems. So nowadays, hardware for AI, there is this is a very important area where people are designing various architectural ways of mapping algorithms, AI and machine learning algorithms in hardware efficient. So architecture is a major thing which comes here, right? So that is how it is going these days.
Okay. Now, again, coming back to the questions that were submitted, there was a very general question like how computer architecture is used in practice. So I think what you meant, the person who raised this question is that if I learn computer architecture, how will it help me later on in my career? That means how I can use this knowledge in practice, right? I think this is what you wanted to know. You see, in computer architecture or computer organization, whatever, what we are learning, we are learning how instructions get executed inside a computer system. And what are the different design alternatives? We say architectural alternatives, non-pipeline machines, pipeline machines, various kinds of pipelines, various techniques to improve hazards, parallel processing. So many things are there. So we are trying to make our instruction execution more and more efficient by coming up with more and more innovative kind of architectures. Now you see, once you know what kind of architecture you have in your base machine, then you will be in a much better position to write your programs or applications. Well, I'm giving a small example. Many of you may have heard about GPUs. People are now doing a lot of parallel processing using GPUs. But what is GPU? GPU is actually graphical processing unit. These are auxiliary processors which were initially designed to accelerate graphics. So whenever you do some animation or gaming, to make that performance better, processors come with integrated GPU chips today. There are separate GPU processors available also. Now, inside these GPUs, there are inherently a large number of some kind of arithmetic units that can run in parallel. So if you know how to program a GPU, so the language of GPU is quite different from the normal instruction set of a computer. So if you know that, then you can possibly convert the problem you're trying to solve into one where you can exploit the massive parallelism that is available. Typically, inside a GPU, there are thousands of such small, simple processing units. In contrast, in a processor level, we talk about i3, i5, i4 Intel processors with 2, 4, 6 or 8 cores, not more than that. But here we can have thousands of such small arithmetic processing units that can run in parallel. So in this way, you can see, if you know that I have a GPU with me, but you need to know what is the GPU architecture like inside, only then you can write the program to exploit that hardware. So knowing computer architecture is essential to become a good programmer. Okay, this is my take on this question. So let me see if there are any more queries. Yeah, there is one question from Akash Vaibhav. Let's see what he has asked. Thanks a lot for the course. I am an ASIC design engineer and am planning to pursue PhD in computer architecture. Can you please suggest which area I should explore? Look, Akash, it is very nice that you are looking forward to a, you can say, to a career where you want to pursue PhD in computer architecture. Okay, let me tell you, this computer architecture is not a very common area where people do PhDs. The reason is you need to spend more effort. You have to have a passion in computer architectures. Generally, we call these systems: computer architecture, computer network, operating systems. These all generically we call systems. Well, any research effort in systems involve a lot of effort. But what you have raised the question or your desire, that is excellent, very good. See, in computer architecture, there are a lot of areas you can think about working on. Like one is, of course, developing better and faster parallel architectures where you can run things faster. better implementation of these instruction set architectures? Well, the thing is that over the years, over the decades, lot of advancements have already been done, and it is very difficult to do anything which is very radically different anything. Okay, so this is one area. And another big challenge that we face today is that the processors, the hardwares are becoming faster with time, but the memory unit, the data transfer rate that we can support is not increasing at that same pace. So having better kind of memory technologies, this is one very key thing. And with the emergence of these embedded systems, IoTs and other things, all these small architectural concepts are getting distributed. So that is also a very big challenge. You see, tomorrow we'll be seeing so many kind of devices which you can wear in our body. Like in our wrist, we can have a band, which will be actually be a processor, which will be sensing certain parameters directly from our body, and it will be communicating the information to somewhere else. It can do some local processing also. So these are all examples of customized computer architectures. So tomorrow, in the years to come, we shall see more and more applications of this type, and these are all research areas. And of course, needless to say, you must have heard about something called quantum computing. That is something which is, of course, very distinctly different but very important. You see, to understand how quantum computing works, you need a good understanding about quantum mechanical principles. May not be the details, but at least some of the basic concepts. Now, major companies like IBM, Google, Microsoft, they are working towards developing quantum computers, and small scale machines are already been built. So the day is not far where we will be having a commercial scale useful quantum computer. And once that happens, a lot of things will change in our daily lives. Our internet, the security that drives the internet, that has to be revisited, because most of the security algorithms and protocols that we use today, they will all be broken if we have a quantum computer. So these are some of the areas you can carry out your research. Gurudev Sajwan has asked, what course should we take after this course to advance our knowledge in computer architecture? Well, Gurudev, I would suggest that number one, you should have some knowledge of some hardware description language. So some course on Verilog or VHDL will be good. Secondly, in order to have a better understanding about hardware implementation, it will not be a bad idea to go through some course on VLSI design or physical design automation. Okay, because if you go through that course, some of the things that we have discussed in this course, but not to the depth. Now, in terms of the actual VLSI implementation, chip design, ultimately you have to design the chip. So at that level, you can think of the different trade-offs and other issues that can come in. Low power, we look for low power implementations today, and so on and so forth. So these two things come to my mind right now. Some course on hardware description language, some course on VLSI design or physical design automation, this kind of, okay. Assignment detailed solution of last year's. Yes, that should be possible. We can ask our TS to share that with you. That should be possible. But the main questions we cannot share. The main means end semester questions. That question paper we are not supposed to share. So, Professor Datta, do you want to add to anything?
No, not much, sir. But yes, please share your views and other things in the forum. We would like to help you out. as much as possible, and go through the course. For the final examination point of view, I would suggest all of you to go through the assignment questions very nicely, and of course the concepts. So one point I would like to share that will be helpful for your final end term examination, final paper, maybe like for the problems that we have been solving in the assignments, you have been solving in the assignments, you can go through those very nicely. Apart from that, so there are many things like Booth's multiplication, um, adder addition, and then other things, that division that we have performed, floating point addition, and etc. Try to do a step-by-step thing properly, because that will help you to solve questions that may be coming in the final uh, final end term examination. Yeah. So if you have any doubt, do share us your things in the uh, forum. We will be happy to help you out.
There, Akash was trying to ask some question.
Yes, of course. So
Okay,
Akash,
I mean, Akash is asking one more question. It's interesting. He's asking that can the two fields of computer organization architecture and VLSI implementation can be integrated in computer architecture research? Well, my answer would be unless you integrate the two, the research will not be meaningful. Because in VLSI, you are saying that how you are actually implementing the thing. In architecture, you are talking about how to organize the different hardware modules to implement certain things. You cannot think these two in isolation. To be a good researcher, you need to understand how these modules you're talking about in architecture, so how these are actually implemented in VLSI. So you need to know both. Yes, you are absolutely right. And okay. And just another thing I would like to say that as part of this course, if you see that we have tried to discuss a lot of problems, we have tried to solve a lot of problems as part of several lectures. Now, if you look at the typical GATE question, the kind of questions that appear in GATE, we have tried to cover that to some extent. So if you go through this course carefully and seriously, cracking the questions in GATE in computer organization architecture should not be a problem at all, because you'll see that there are questions that come with respect to Amdahl's law, with respect to pipelining, with respect to cache memory, memory hierarchy. So all these things we have tried to cover, and also we have done a lot of problem solving. So in the GATE examination, similar kind of problems typically come. Okay. System architectures for ethical hacking. Yes, absolutely. Absolutely. These are all very good areas of research. This ethical hacking is just one area or one example you have given, but you talk of any example, any field, like AI and ML, you need to have customized architectures which can best, you can say, run or give better performance with respect to the applications you are running. Okay, so this is absolutely correct. Another thing, I think Professor Datta will also agree that in NPTEL you'll find that there are a lot of other courses on computer organization, and we have deliberately tried to make this course a little different from the others. we
Yes.
try to start from the
Yes.
basic introductory concepts and advance towards, you can say, some more, you can say, means intricate concepts like pipelining, parallel processing, and so on. So if you look at the typical undergraduate curriculum in many colleges, you'll find that there are typically a first level course on computer organization, followed by a second level course on computer architecture. But in this course, we are possibly trying to cover aspects of both these, starting with computer organization and then moving on to computer architecture. So for some of you, it may appear that the course contents are a little too heavy, but yes, we have done it deliberately so that you have a very broad coverage of the field. Gurudev, Verilog and not VLSI design, I have another course called Physical Design Automation, which does not purely talk about VLSI design, but rather talks about the different steps in VLSI design. That means when you do a translation from some kind of specification to a VLSI chip, what are the intermediate steps that you have to go through, the computer-aided design tools. So these two courses actually I have offered on NPTEL. These are available.
I would like to add one. There is a one course in NPTEL which is given by a professor from IIT Guwahati for advanced level architecture. He has taken up many other architectural tools that are used to analyze an architecture better. You know, so you can also go through
Those are
that
for
course.
analyzing architectures, right?
Yeah, those are for analyzing architecture. So you design some architecture and then you evaluate that how good is your architecture based on certain parameters and all. So you can go and take up that course as well.
And another thing is that for those of you who are interested to learn about embedded system and hands-on designing using some embedded system board like ARM, so myself and Professor Datta, we also have a course on embedded system design using ARM. That course is also available. Okay.
And that will be floated in next semester.
Yes, next semester that course will be running. So are there any further questions? So I think there does not seem to be any more questions. So I wish you all a safe post-COVID time, because I understand that all of us are going through very difficult times. Well, network security, I do not have any course, but there is a course on ethical hacking where a lot of issues of network security are covered. So ethical hacking, next time when it will be offered, you can go through that. So ethical hacking and network security are very related. Yes.
So there is one question to be asked by Akash Vaibhav. So let's wait for.
Yes, yes. See, Akash, to start with, this kind of computer architecture course is like you can say these are basic level courses. And you're right, compiler and computer architecture go hand in hand. They are very much related. you you need to understand compiler, because a lot of compiler technologies, they very much depend on the underlying computer architecture. So when you want to do research in this area, understanding how a compiler works is also important. And of course, beyond the courses, there are a lot of advanced level books. You will have to read them. There are a lot of technical papers which are published in journals and conference proceedings. You will have to look at them, because all of those things you will not find in books. Okay. On some
Uh,
specific areas, specific topics, the researchers have done some kind of research and they have reported their results. Okay. So you will have to go through them.
oh,
But I
so then,
believe this background with this kind of course is good enough. You need to have some knowledge about VLSI design also. Compiler is good. Yes. So I believe you have built the platform for you. So from this platform, you'll have to start your research.
so there is one question on how the computer architecture used in practice. So would you like to
Yeah,
take
that
this?
I mentioned. I addressed this question. I told that computer architecture knowledge helps you in many applications. I told about the GPU example I gave, that if you have some applications in parallel processing, you need to understand what kind of computer architecture is available with you, like GPU. Then there are some special programming language you have to use to exploit that hardware. So that understanding that hardware is important.
And somebody has asked regarding that question on stack in MIPS. You already explained, but
Yes,
they
yes.
want to tell them regarding an example on factorial, and we can do it. I would strongly suggest first that you should try it first yourself, that how to do that. We have worked out a lot of examples on QT some of the examples that you can perform in QT. So we will share you this solution as well, but I would strongly suggest you to try it at your end first.
So, Vaibhav, Akash, you have asked for some top conferences and journals. There are, uh, there are in fact many very good conferences and journals which are available in this area. Some of the top conferences I'm remembering right now are DATE,
Yeah, I also.
DAC, ASP DAC, and Dr. Professor Datta has mentioned ICCAD. These are some top conferences. And regarding journals, typically these IEEE transactions, IEEE transactions on computers, IEEE transactions on computer design, then ACM transactions on architecture, transactions on VLSI. These are all very standard journals. So you need to just refer to these. Circuits and systems, TCAS, yes. These are all very standard conferences and journals. So it is really nice that some of you are seriously thinking about doing research in this area. So we don't have much time. If you have any questions, you can ask quickly. Okay. So it's so Gurudev, there are a number of certification examinations which are there in various areas. I don't want to mention it here right now. For example, if you are a professional who want to get some certification in ethical hacking, there are a number of agencies which give certifications on ethical hacking. Say on networks, typically Cisco provides a number of CCNA kind of certification. So there are many such. So if you do a quick search on the internet, you will find all this information, that in which specific area you want to have this certification. You will get all information. But just a word of warning, you should get certification from a reputed place. Many small unreputed institutions also provide certifications, but they do not carry much value. Okay. So thank you all of you for joining this live session. Okay, NPTEL certification. Yes, there are. NPTEL is having some plans. You can directly look at the SWAYAM website. You'll get some information there. They are planning to float some kind of a diploma program. If you have done some set of courses, completed them, you will get some kind of a certificate or a diploma kind of a certificate. So they have some plans. NPTEL has some plans. So let us thank all of you again. Professor Datta, you want to?
Thank you. Thank you all, and all the best for your assignments as well as for the exams. I hope you are liking this course, and we will be surely there to help you out.
Okay, stay safe, all of you.
Yeah,
Thank
stay
you for
safe.
joining today. Thank you.
Thank you.